Hi everyone, my name is Jakub Szymaszek and I'm a program manager in Azure data team at Microsoft, and I work on various security features across the SQL product line. In this presentation, I will talk about the new and exciting technology called Always Encrypted with Secure Enclaves, which we shipped in SQL Server 2019 last year. We'll discuss confidential computing capabilities Always Encrypted with Secure Enclaves enables. But first, let me start with describing the problem that Always Encrypted with Secure Enclaves is trying to address. As you probably know, relational database systems traditionally protect solutions for protecting data, provide solutions for protecting data at rest and in transit. In SQL Server, these roles are fulfilled by transparent database encryption and transport layer security. However, neither technology helps protect sensitive data or data in use, and that's the gap Always Encrypted is trying to address. So why is protecting data in use important? Without technologies such as Always Encrypted, potentially malicious rogue administrators, hackers, and malware can quite easily exfiltrate the data from the database. For example, a DBA can simply run an arbitrary query against the database, retrieving arbitrary data in the clear. Similarly, administrators of operating systems on machines hosting SQL Server instances could exfiltrate the data in multiple different ways, for example, by scanning the memory of the SQL Server process. So what we want to protect the data from such attack vectors, from such powerful and unauthorized high-privileged users. We want to make sure that these users cannot see the data, at least not in the clear. On the other hand, we want to make sure that applications, authorized users, owners of the data can see it. And also, what's probably the most important here, we want to ensure that the database system remains useful. What I mean by that, we want to ensure that the database system can continue process queries on the data while the data is being protected from admins, hackers, and malware. And we call this vision confidential computing. We started the journey towards this vision in 2016 when we released the initial version of Always Encrypted. It provided quite basic confidential computing capabilities, namely it enabled equality comparison and point lookup searches and equality joins. Now we are expanding substantially these confidential computing capabilities by leveraging the technology called Secure Enclaves. So let me explain what an enclave is. An enclave is a region of memory and a process containing it, and it has very special properties, namely it's a black box to the rest of the operating system. Even the containing process cannot access the memory of the enclave and cannot manipulate the code running inside the enclave. There are two concrete enclave technologies that I want to call out. One is Intel Software Guard Extension, or SGX, and the other is virtualization-based security enclaves in Windows Server 2019. This is the enclave technology that we are using in SQL Server 2019. With VBS enclaves, the entity that ensures the enclave is the black box to the other processes and the operating system is Windows Hypervisor in Windows OS. So here's a screenshot that illustrates this idea of an enclave being a black box. If you can connect a kernel level debugger to a process containing the enclave, you won't be able to see what's inside the enclave. As you can see here on the screenshot, at most you will be able to see the question marks or basically some garbage instead of the actual data or code that runs inside the enclave. So now, how are we using this concept of enclaves and leveraging these technologies in SQL Server. Well, so we expanded the Always Encrypted in SQL Server 2019. We preserved the basic, the foundational design of Always Encrypted, which is the data is encrypted, decrypted inside the client application, and the server never has access to the keys or the data in the clear. But now we have expanded SQL Server process with the enclave. And inside the enclave, we put an implementation we packaged as a library the implementation of the logic that is triggered when you run various predicates and SQL queries, and we also put their implementation of always encrypted cryptographic algorithms. So we package all that as a library, and we put that library inside the enclave. And now, during query processing, SQL Server, SQL client driver first submits the query from the application with parameters, and now the enclave the SQL Server delegates computations on encrypted columns to the enclave. It sends the encrypted data from encrypted columns to the enclave along with query parameters, and the enclave now decrypts the data so it has access to plain text, and now it can perform computations on the data in the clear, many more computations than we could support before. So with this technology, we support pattern matching, using like predicate range comparisons. We enable these operations on randomized encryption with indexing. Sorting, by the way, is not supported yet, but that's something that we are working on. We also enable in-place encryption. So what does this mean? If you're familiar with Always Encrypted in previous versions of the feature, you know that in order to encrypt a column, you need to move the data outside of the database, use a tool like Always Encrypted Wizard to encrypt the data and upload it back to the database. Of course, this is a very painful and cumbersome process. With enclaves, we can encrypt data in place. You don't have to move it outside of the database, which is a huge performance improvement. So with the introduction of enclaves, we also introduced certain design challenges, namely, one of the questions that pops up is an enclave is expected to be an extension of the client trust boundary within the SQL Server. It's supposed to be an agent representing the client application within the SQL Server process. But now the question is, how does the client driver, the application, know that this enclave is really trustworthy, that it's a genuine VBS enclave running the SQL Always Encrypted library inside, instead of some malicious code dumping your sensitive data somewhere? And so we are addressing this problem by introducing an attestation protocol. Before the client authorizes the use of an enclave for query computations, it triggers the attestation workflow, which involves reaching out to an external attestation service, which verifies that the enclave is trustworthy. It runs the correct code, and the correct code runs inside the enclave. In SQL Server 2019, we are leveraging Windows Host Guardian Service as an attestation service. It's a role in Windows Server 2019. You need to make sure that it is available. It runs in your environment on a different machine or a set of machines for high availability. The other challenge that we had to address in the design of Always Encrypted with Secure Enclaves is how to hydrate the enclave with the right keys. As I mentioned earlier, SQL Server doesn't hold the keys, column encryption keys that protect data encrypted columns, but I also mentioned that enclave in this design needs to decrypt the data so that it has access to plain text to support rich queries, for example. So how does the enclave get the keys? We address this problem by implementing the secure key release protocol, during which the client driver negotiates a shared secret with the enclave that establishes a secure channel or secure tunnel between the client driver and the enclave, and then the client driver releases or safely passes the encrypted column encryption keys to the enclave, which can decrypt it with that negotiated shared secret. So with that, let me transition to the main part of this presentation, which is a short demo of Always Encrypted with Secure Enclaves. For my demo, I will be using a simple database, Contoso HR, with just one table. And let me show you what this table contains. So it contains information about employees, including their national identification numbers, SSN, social security numbers, and salary information. And as a DBA, I'm using this instance of ADS, Azure Data Studio, as a database administrator. I can, of course, see all the data in the clear. I can freely copy it and steal it if I want it, right? That's the problem that we want to prevent. Now, I also here have a sample web application, which allows me to view that data and also filter it by salary and by a portion of the social security number. Every time I use this UI, this application triggers a SQL query. So let's see how these queries look like. So let me run this query here, which I have an extended event session configured, so it fetches extended events from that session, and that allows me to intercept the queries in my application issues. Let's find the query in this X event. Here it is. Let's copy it to another window so that we can examine it. So here is the query that the application sends to SQL Server. It's a select statement fetching all columns from employees table, but I want to call out this where clause, which contains pattern matching on social security number columns, less than, greater than comparisons on the salary column. So what we want to make sure, we want to ensure that the data the data is protected from TBAs, but the application can continue function without any changes. And in particular, these queries are still processed inside the database system without any changes. So that's our goal. Let's clean up here a little bit. And let's now enable Always Encrypted with secure enclaves for this database for relevant sensitive data columns. So for that, I'm going to switch to another instance of Azure Data Studio. When using this instance, I will be playing the role of a data owner, somebody who manages the keys and configures Always Encrypted for the database. So again, I'm connected to the same Contoso database. I have pre-configured this environment a little bit because we have limited time, so I made sure that the attestation is configured using Host Guardian service for the machine hosting SQL Server. I have also configured cryptographic keys for Always Encrypted, column master key and column encryption key. So here they are. I'm showing them to you in the Object Explorer tree. And also we can view their metadata here. So master key is a certificate, and column encryption key is of course stored in the encrypted form. SQL Server doesn't know the plaintext of the column encryption key. So now with all that set up, I can encrypt my columns, and without enclaves, I would just open the tool like Always Encrypted Wizard or use PowerShell to encrypt my data. But here I don't have to do that. I can encrypt the two columns that I care about using a simple alter table statement. And that is not possible without enclaves. And when I do that, let's actually run this query. It's completed instantly. My data gets encrypted inside the enclave without being moved out of the database. I want to call out, however, one important configuration aspect here. Mainly, I am connected to this database with in a very specific way, and namely, let me minimize this further so that we can see in the advanced properties of the connection, you can see that I have configured Always Encrypted for my connection, and I'm also specifying the attestation protocol and the attestation endpoint for my application, which in this case is Azure Data Studio, so that it can trigger the attestation and verify the enclave is secure before using it. Okay, so we have encrypted our columns that actually check and confirm they are indeed encrypted. So here is the query we ran before that showed the data in the clear. I switched, by the way, back to the instance of ADS, which I'm using as a DBA now again. Let me rerun this query. So you can see now that the columns, SSN salary columns, are encrypted as a DBA. I can only see ciphertext. I can still perform my DBA tasks, but I cannot see sensitive data in the clear. So that's great. We achieved that goal. Now let's go to our application and let's see if it still works, right? So can we filter by salary? Yes, we can. Can we filter by a portion of the social security number? Yes. Let's actually, I want to show you one thing. So this application changed, works unchanged. I didn't change anything in it, in the code at least. I want to call out, however, that I modified before the demo. One small aspect of the connection string and the data and the web config file for my application, which is that's a .NET application. Here's the connection string. I enable two properties. I included two connection string keywords, enabling Always Encrypted and specifying the attestation protocol. The same thing I did to ensure that my alter table query for encrypting columns worked in ADS before. So that's what you need to do to make sure that your queries inside your application can use the enclave. Let's go back to extended events. Let's fetch the fresh extend events, so that we can see even how the queries this application sends, how they look like and if they changed. So let me copy the current query. Let's paste them in the same window as before so that we can compare the previous and the current query side by side. So it's still select statement, the same workloads, nothing has changed. And as you saw in the application, it still works, returning the right results. One thing I want to call out is that before, in these queries, passed the query parameters in the clear, right? The portion, the pattern matching pattern for searching SSN column, min salary, max salary. Now, with Always Encrypted enabled, these query parameters are passed as ciphertext. They get encrypted on the client side. Now they are then passed to SQL Server. SQL Server passes these encrypted parameters to the enclave. The enclave decrypts them along with the data stored in SSN salary columns and performs comparisons, performs computations on these two columns in this black box environment. So to summarize what we demonstrated in this demo and what we talked about in this short session, let me go back to the deck. So Always Encrypted, as you saw, it protects data from administrators, including DBAs. In our demo, DBA couldn't see the data after we encrypted the columns in the clear. They couldn't see the data in the clear. But as you saw in the demo, confidential computing capabilities, rich confidential computing capabilities, pattern matching, range comparisons still worked after we encrypted the columns, and we could encrypt the columns in place without them moving the data out of the database. Let me suggest a few ideas for the next steps for you. If you haven't tried this feature yet in SQL Server 2019, I would like to highly encourage you to do so. We have some excellent resources online, including tutorials and GitHub samples. I also want to say to those of you who are looking forward to using this feature in Azure SQL offerings, database managed instance, if you are interested in this, Always Encrypted Secure Enclaves is not available yet in our PaaS services. But if you are interested in it, if you would like to see it there, we have a short survey for you. It would be great to get your feedback, and this will give us an opportunity to ensure that we keep you in the loop about upcoming previews, and we'll keep you informed about the developments around Always Encrypted with secure enclaves in Azure SQL PaaS offerings. With that, I'd like to thank you very much for watching, for your interest in this exciting security technology. Thank you very much.